Good morning. Chapter 13, we actually get to mix in a little bit of statistics with finance. It just doesn't get any better than that, now does it? I mean, golly, that's why you came to college in the first place. So you could talk about statistics and finance, right? And at the same time, kind of talk about statistics and finance. So away we go. You guys, your assignment is 1, 2, 4, 8, 13, 16, 7. You probably can't even see that. 17 and 22. So I've done some that are pretty similar, like number 1, in fact. And I changed the numbers, obviously, and you'll find my numbers are a lot lower. Now, the thing is actually, the way I have it set up, I could easily plug in the numbers. So a little bit of advice, if you want to set it up exactly like I have it here, change these numbers to what's in the book, and boom, it would be done. You might have to do the ranking, then might be different. It might turn out different, so you might have to check that. Here we go. Anyhow, so what number 1 is talking about, we're going to talk about coefficient of variation here, and coefficient of variation tells us how big or small the standard deviation is, basically, okay, or the variation. And that usually denotes risk. The bigger the variation, the more risk that's typically involved. There's a figure or a number that you'll see when you guys are doing your second report. I didn't talk about it, I don't think, when I talked about Under Armour. It's big news about Under Armour. But anyhow, and it's called beta. And beta is really something that's very similar because it talks about the relationship of the movement of a particular stock with the market as a whole. And stocks that move a lot more than the market as a whole have a riskier, I think, a higher beta, whereas stocks that move kind of in conjunction with the market have a beta of about 1, and then stocks that move less than, even less risky, have a beta that's less than 1. And we'll look at some of those, but the idea here is to take a look at investments and kind of analyze the risk, based on some of the factors, in this case expected value and standard deviation, which numbers that are given to you for problem number 1. Now, I put in some different numbers. I just put 12, 15, 9 for my expected values, my standard deviations of 4, 7, and 2. And what's the standard deviation? It means how far a normal value or a value in this set differs from the expected value. How far? If there was a bunch of values, it's basically the average of the difference between that and the expected value. Okay, so if this number, if the standard deviation were really small, okay, that means that all of the values that you come up with are pretty close to the expected value. If the standard deviation is big, like this one, really, relative to that, of course, that means that the average values are quite a ways away from what the expected value is. So if we're looking for less risk, we would want this number, or variation number, to be smaller. Okay, coefficient of variation to be smaller. Anyhow, the formula is really simple, right? It's just simply the standard deviation divided by the expected value. So this is just equal to the standard deviation divided by the expected value. Okay, and in my case, that one's 333. And I can drag that formula down. Okay, the smallest one is 0.222. Okay, there's actually a ranking program I could look at and put in there, put in here. And but I didn't. I just kind of did this manually. I know it's really hard, but I did it manually. Okay, and so this one is the least risky, or it would be my preferred investment if I were in fact risk averse. Okay, my expected value may be smaller, but if I'm risk averse, this would be the investment that I might prefer. Okay, and that's kind of what it's asking there. I think I went to number 3. Oops, sorry. I went to number 3 over here. Well, I got these in different ones just to kind of walk through what your guys will look like. You guys have 2, and I think 2 is pretty similar to this. Talks about Samsung Corp is evaluating the introduction of a new product. The possible levels of unit sales and probabilities of their occurrence are shown. And I think we've done, some of these before, really. And so we've got the sales in units. Do I have the same numbers? I think I got different numbers, don't I? 20, 40, 55. I got number 2. I called it number 3, and you guys, let me check here. Ooh, you guys have number 2 assigned, so I don't want to look at that. Dang. I need to do number 3. But actually number 5, I think, is the same. Why would I have done your guys's and had the wrong number on it? Shame on me. Let's jump ahead and look at number 5, because I think it is set up quite similarly to number 2, which you guys have assigned. Okay, and it's certainly the same as number 4. 2 actually just does you don't go quite as far. You don't calculate the coefficient of variation, but everything else is pretty much the same. You got 4 deals here instead of 3, but set it up and set these up very systematically, and I think you'll find that it'll work better. So, I've got my labels, my possible outcomes. If it's ineffective, normal, or effective for number 5, my Al Bundy's evaluating a new advertising program. Compute the coefficient of variation. So my units, if it's ineffective, are going to be 40. If it's normal, 60. But if I have a good outcome, it's going to be 140. What I think the probability of each outcome is 20% ineffective, 50% effective, and 30% is effective. Okay, that's got to add up to 1, and it does. Okay, and you could check that. Sometimes you should, maybe. These ones aren't very complicated, but if you were doing one that was quite a bit bigger, you'd probably want to verify that this is equal to 1. Okay, so like we've done in the past, then we take our probability times our number of units, and so this is going to give us our expected value, right? So this is simply equal to my probability times my number of units, and I can drag that down. Okay, and then I need to calculate the sum of those, and that's going to give me my expected value. Okay, it's 80. Okay, now I've got to calculate. Here's where the stats comes in. Sorry. Okay, stay with me here for a little bit. Most of you should have had stats already. So we figure standard deviations, and standard deviations is, again, how much does our outcomes here deviate from what we think our normal outcome might be, right? What our calculated outcome might be, what we think is the most probable outcome. Okay, so it's simply this minus this. Okay, you could actually do it the other way, and your answer would be the same if you subtracted this from this. Okay, but I'm going to do it this way. This minus that. Okay, because all we're doing is trying to figure out how far in units it is from this normal, right? And that's 40 units. Boom. I can't just copy this one down, right? Because what I should have done is made my C8. If I wanted to copy it, I should have made my C8 with dollar signs like that. Now I can copy it down. So, oops. Except, yeah, there we go. Uh-oh. Nope, I screwed up. Oh, I didn't. My C8 isn't the one. It's my E11 that needs to be. Gosh, dang, I'm just horrible. Let's just try this again. This is equal to this minus this one, and that's the one I want my dollar signs on, so I'll hit my F4. Okay, now let's try that. There we go. Sorry about that. Okay, then I square these, and squaring it really, the only reason we're kind of squaring this, as you'll see later, because we'll end up taking the square root, sort of, is to get rid of the negative signs, right? This tells me how far away it is and in which direction, but I'm not concerned about the direction. I'm just overall, I'm concerned about how far it is on average. Okay, and so I simply, that this is equal to this. And here's, if you remember your stats, look at that little house thing that's on top of your number 6. So hit your shift key and your 6 key, and it puts in that little tent thing, okay? So it's this one to the second power. I just type in 2, and that'll square that, okay? And then that I can do that, okay? Now I take these values, so this is how far on average it is from my kind of expected value, okay, and then I've squared it to get rid of that, but I just got to put my probabilities back in here because this number doesn't really have any of the probabilities in it, and so I put my probability back into it, which is this times this, right? So this is equal to my probability times my squared, okay, is equal to that, and that one I can just drag down, okay, and then I can do a sum or a total of these, and that gives me my variation, okay, and because I squared these, then to find my standard deviation I need to take the square root of this. Okay, there's two ways to do that. There is a formula, as you can see up there, that's square root, and I'll maybe show you both ways. So I can click on this. I can come here. I would go to statistical, I believe, and I'd come down here to PQRSQ. Oh, I don't see square root in there. So let's go to math and trig. There it is. Square root returns the square root of a number, okay. So what's the number? I just click on that and hit enter, and it's a done deal. Okay. You can also, and sometimes it's a little bit easier, it can be quicker, you could also say this is equal to this. Use my little tent thing again above my 6, and then I use a parentheses to the 1 divided by 2, or 1/2 in parentheses, and that's actually the same thing, okay, which gives me my square root of that, and that's also my standard deviation. Now my coefficient of variation is my standard deviation divided by my expected value. So this is my expected value, this is my standard deviation, so I figure my coefficient of variation is equal to my standard deviation simply divided by my expected value. So I got a 50, right? It's higher than any of these if I was comparing them, and I'm not. That'd be apples to oranges, but it would be the higher of those, right? Okay. So your guys' 2 is just like that, except you don't have to figure out the coefficient of variation, but you do have to calculate the standard deviation, which you just do right through there. So going on to number 7. 7 says, oh man, 5 investment alternatives have the following returns and standard deviations. This is just like your number 8. It says using the coefficient of variation, rank the 5 alternatives from the lowest risk to the highest risk. So really it's just like number 1 again. I mean, you could copy your deal, right? And then you just got to input the numbers. So I've got 5,000 with standard deviation of 1,200, and so it's simply equal to my standard deviation divided by my expected outcome, and there it is. Okay, and I've input all my data, and you guys can as well, and I drag that down, gives me that. Let's see, I did. Look at that. Okay, so there is a program, and it's called rank.average, right, that will tell me then how these are ranked, okay, and you can either go from ascending or descending, okay, and in this case it kind of doesn't matter. What you need to do is label these for me, because my question says using the coefficient of variation, rank the 5 alternatives from the lowest risk to the highest risk, okay. So I've got my 5 is the lowest risk because that's 0.090, right? The highest risk is 0.40 if you compare those, okay? But how do I use that rank average formula? It's kind of cool. I'll just hit delete, and let's see if we can come up here, and I believe that that's a statistical. rank average, right there, returns the rank of a number in a list of numbers, its size relative to other values in the list. If more than one value has the same rank, the average rank is returned. So that's why it's called average, because if two of these were the same, it would make each like 3.5 versus one being 3 and one being 4. Okay, and I don't want that. So my number is this number that I'm comparing, right? Okay, and so that one I leave, and then my reference is from here, and I'm going to hit F4 through here, and I'm going to hit F4 again. Oops, I guess when I hit F4 it does all of them when I do that. So okay. And then I can say, let's see, order is the number of rank listing. Do I want descending equals 0 or omitted, okay, or ascending, okay, any non-zero. So I can put a 1 in there, whichever, and I think I've got these as descending, okay. And there you go. Is that the second? It's descending, so is that the second highest? Yeah, it would be. 0.40 is the highest. This is the second highest, third highest, fourth highest, fifth highest. So that's the highest, that's the lowest. Okay, and please make sure you label yours too, so we kind of know. Oh, bouncing on 7. That's like year 8. So we go to 13. And I think I did 13 and did it the same way, but I just made up some different numbers. So Waste Industries is evaluating a $70,000 project with the following cash flows. So I've got similar things. And so the coefficient of variation for the project is 0.847. So it gives you the coefficient of variation. Now I made my own up. I said 0.732. Because the only thing you really got to do on this now is look up what the discount rate's going to be. Okay, so based on the following table of risk-adjusted discount rates should the project be undertaken. Select the appropriate discount rate and then compute the net present value. You know how to do the other stuff, so really all you're doing is looking up in that table there. Now, yours is different, but in my case, my coefficient of variation is 0.732, so if I look down, that's the one that's between the 0.51 and the 0.75, right? So my discount rate is 10%. Yours is probably going to be different. So I plug in my discount rate. I just plugged it in there. I said my investment was 40 grand, and here is my list of cash flows, right? So then we go back and do what we've done in the past, and that's just a net present value calculation. I'm going to cancel. I'll just delete it and do that all over again. So I do a net present value. It's probably fairly recently used, so I can click on that. Okay, my rate's my discount rate, right? And my values are just these, okay? I don't include the investment, okay? So my net present value of those using that discount rate is only $39,341, so I'm not even getting my money back, right? So I would expect my internal rate of return to be less. It's not required, I just calculated that for the heck of it, okay? So you need to compute, here's my actual net present value then, as I have to subtract this from this, right? And so I'd have a loss of $659 calculated as a net present value for this particular investment, so I would not want to do that. All right. Jumping ahead to 16. I gotta do this. I did 16 as well, but I did something that was similar. Okay, this one seems to have caused confusion in the past, and mostly it's just a reading or an interpretation of the problem, and that is we have our probabilities, right? When I go to 16 and read it, it says Debbie's Dance Studios is considering the purchase of new sound equipment, and not unlike some of the other problems that we've had, right? We've got cash flows based on how the equipment's going to work, right? And our estimate of how the equipment's going to work, and so we apply some probabilities. Now, my numbers are completely different, so please don't use my numbers. Use your numbers that are in the book, right? And I've got my probability here. I got them kind of backwards from the way it was in the book, sorry. But I put my probability and then my cash flows here. And so I just multiply, again, my probability times my cash flows. Okay. and that gives me that. And then I do my expected outcome. You know, I copy this down first, okay, and then I calculate the sum of those. Okay, so if I get $6,060, and I put in that my investment was 24 grand. Okay, but I'm going to have a $6,060 cash flow for each of the next 5 years. That's where it seems to get. I don't know why people seem to put in the different numbers for cash flows. Once you do this number, when you've calculated based on your probabilities and the expected cash flow for each of these probabilities, okay, that gives you an overall expected value that you plug in for the next 5 years. So I just did 60, 60, okay, and then copy that down. And then again, we're just back to calculating for 16. It says, what's the expected value of the cash flow? Okay, I got that. The value compute will apply to each of the next 5 years. So there's my expected value of the cash flow. What's the expected net present value? Well, I didn't complete this one, so I'm going to have to do that. So I've got, I don't know why I put it up here either, but anyhow, I'm going to calculate my net present value. My rate is, what's it tell me? My cost of capital is 15%. Now I don't have that entered anywhere in here, but I can just plug that in. Okay, so I'm going to plug in my 15%, and my value then is simply these 4, right? Or 5. I'm sorry, 5 years. Okay, so my net present value, I think I'm just going to change this to NPV. There we go. Okay, is 20,316, or that's the net present value of these cash flows. My net present value when I consider my investment is equal to this minus this, but that's a negative, so I got to use my plus sign. Okay, so I'd lose that much money, right? And my cost of capital is 15%. I did an IRR just for the heck of it. Okay, and I would expect that this would come in well under 15%, and it does. So should I do that? And my answer is no. Your guys' answer might be different. 17 is just, it's just a little long one to set up, and it's just one of those that has more numbers, but it's doing the exact same thing that we've done. You guys have an Australia mine and a U.S. mine? Yeah, I did Alaska and Montana. How's that? 2 great places to be. And for mine, set it up with your investment up here. Your guys' investment numbers are obviously different. Now the years and stuff that I set up are similar. If you look at the first one, in your guys' case it's the Australian gold mine, but in the Alaska gold mine. So I'm going to have 0, and I need to put these in. Okay, I need to put in the zeros. Years 1 through 4, put those in as a 0. Okay, then for mine, my cash flow says for 5 through 15. Okay, this is why I went ahead and put these numbers in over here, and I'll show you how to do this probably the easy way. You guys probably all know how to do that, but if you just start up here and go 1 and then 2, that's all you have to do, and then you highlight both of those, left click and just kind of highlight both of those, and then if you grab it, it knows that you're going to count, and it actually does it for you there, if you can see that in the small little numbers. Okay, boom. Now I did that because now I can follow along. 5 through 15 is actually 11 years, but I don't have to worry about that. I just need to know that I'm going to have 400 grand from years 5 through years 15. So if I do this, and then I just drag that down to 15, boom, okay. And then I'm going to have 800 grand for mine for the last until year 25. So 800. Okay. And again, I drag that down. Okay. You guys, on the other hand, or Montana. I'm sorry. You guys, like I'm from Alaska, and you all are from Montana, and I'm a Montanan. I was in Alaska once. Okay. So I'm going to have a steady. I'm going to have a $2.4 million. Oh, maybe one too many. Investment, but I'm going to have a steady starting in year 1, 300,000 for all 25 years. So I just drag that down. Okay. Then we're just going to do a net present value calculation, right? Okay. And that's why you got to have the zeros in there, because to calculate that, you just need that in there. So let's just delete that for now, and then we'll come up and do our net present value, right? My rate for both of them, does it tell me? It says my cost of capital is 13%, but I think I used 12% for my problem. Your guys' is 13. Please use your 13%. And then my values are simply these. And again, I need to capture those because we need to know that in those years there's nothing going on. Okay? But I end up with a 2.335 million, which does exceed my investment of 2 million. Okay, by this much, and that I'd calculate simply by saying this plus my negative number here. Okay? And if I did an IRR, it would actually come out to the 13.4%. I do the net present value here. Actually, you know what? I can just then go copy and paste, and I screwed it up. Something. What did I do wrong? Ooh, probably my rate. My rate moved. That's what would happen there. So let's just escape that, and let's just do do a net present value brand new. Yeah, see, there's my rate is 12%, and then my values are those are probably the same, but we'll just do it here anyhow. Okay, there we go. Yeah, 2.35, but I had to invest 2.4. Oh, so that's not so good. So I would lose money there. Okay, but the question goes on to ask, it says if the Australian mine, or in my case if the Alaskan mine, okay, justified an extra 2% premium over the normal cost of capital because of its riskiness and relative uncertainty of cash flows, does the investment decision change? So if I needed to have a 14% here, right, for my cost of capital, all I have to do is come up and enter this, and I could run the numbers again, but ooh, in my case my decision would change then, right? Okay, and I kind of knew that actually when I did the IRR, because it was only 13.4, and so at 14% it would have been insufficient, to pay back that investment. All right, well, let's go. I think we've only got one more to go, and I think that's number 22, and I don't know that I get to show you guys a lot for number 22. I think I just kind of wrote it up and taking a look at it. And what's it say? 22 is Trainer Pie Company. It is a food company specializing in high-calorie snack foods. It is seeking to diversify, the key word there, diversify its food business and lower its risk. It is examining 3 companies, a gourmet restaurant chain, a baby food company, and a nutritional products firm. Each of these companies can be bought at the same multiple of earnings, price to earnings multiple, right? The following represents information about all the companies. So you've got what their sales are, you've got their expecting earnings, and you've got their expected or their standard deviation in earnings, right? And so if you look at their standard deviation in earnings, the gourmet restaurant has the smallest standard deviation. So if you just ask which one's less, using the last 2 columns, compute the coefficient of variation for each of the 4 companies, which company is the least risky. Ooh, got to do that. I was saying the standard deviation, so I would have been wrong. So yeah, do the coefficient of variation, which again is simply, I don't know if I have any of this even set up. Expected earnings, standard deviation. I do. Yep. Right. So you just do the standard deviation divided by the expected earnings. Right. I'll even do one of them for you. So for Trainer, I've got this should be Trainer. Oh yeah, gourmet, baby food, and this should be nutritional products, right? So I calculate my coefficient of variation and figure out which one is maybe the least risky. But what does it ask? It asks which company is the least risky. So I do want to calculate that. So again, it'd be my lowest coefficient of variation. Which company is the most risky? So I just need to rank those, and then discuss which of the acquisition candidates is most likely to reduce Trainer Pie Company's risk, and explain why. Okay, now that may be completely different than less risky versus most risky. So you got to go back and look at just look at the chart that they give you and make your best guess. I can't really show you any mathematics or anything to do that. You're just going to have to kind of figure that one out based on what's in there. So, and you might be able to read the chapter. I know a novel concept there, but that might help. So with that, I'm going to close up for this assignment, and I'll talk to you a little bit later, maybe about some companies. So thanks, and have a great day.